So I'm Chris Maio. I'm a professor of coastal geography up in Fairbanks at the university there, and really happy to be back in Dillingham after about 3 years since we spent any time here. My students have been working here. They were here last year, and it's good to be back, and it's good to see some of the familiar faces here. It's always a wonderful place to be a part of the campus here and be able to stay at the apartment and utilize all the incredible facilities of the applied science lab and other stuff here. I want to start out just introducing our team here. So Seth, come on up and introduce yourself.
Hey everyone, I'm Seth. You see me right here? Yeah, I'm Chris's new grad student. I just moved to Fairbanks in January. I got on with him in the lab. Originally, I'm from Homer, and I graduated high school there, and then I did my undergrad in Juneau. And yeah, after high school, I started fishing, so I've been to Dillingham quite a few times, usually fixing the boat and stressed out. But it's nice to be here and get some quality time on the beach. Yeah.
Good. Looks like I stepped out, but I'll have her introduce herself when she comes back. And Renee Rocky is also likely going to be here, so I'll have her introduce herself once she gets here. So I do want to start out just thanking all of the contributors to this work. This has been a team project since we started, which is about 9 years ago. So we've had a lot of financial supporters. We've had a lot of supporters just helping us with the project and taking measurements and all the other work. So really appreciate all this help. It really shows that to really have a successful project that goes on for years and years and sustainable, you really need a lot of folks involved. You know, you really need a lot of collaborators. Oh yeah, thanks, Deb. That helps. A lot of collaborators and a lot of partnerships to make this stuff work. So thank you to all of these folks that have helped us through the years. And so for today's talk, we're going to first kind of give you a little background of the Stakes for Stakeholders project and when we started here 9 years ago. So we'll give you a little synopsis of that. And then we're going to give you some updates. Really, I see this as an update report on some of the results from the past 9 years of research and some of the stuff that we've been working on recently. And then we're going to talk, we're going to let some of the grad students talk a little bit about some of their research, which is kind of the ongoing stuff that's happening. So that's a look at our talk for the day. And there's Aisha, going to introduce yourself.
Hey, my name is Aisha. I'm a PhD student from Pennsylvania State University working under the Polaris project. I'm doing my PhD in sociology, rural sociology specifically, and demography. So I'm here in town to do some interviews with people, the residents of the town, and I'll be here next Tuesday, this Tuesday, yeah. So I've been talking to folks for since last Thursday, so I've learned a lot about the community from the people who were kind to me and had conversations with me. So sometimes I talk to them for 30 minutes, but others lasted at least 2 hours. So it was great. I've been hearing a lot from, about community, how things are going, and I'll tell you more about that later. So nice to meet you.
Thanks. Yeah, and so we're looking at the issues that Dillingham is facing in a lot of different levels. It's not just like the rate of erosion, which is kind of my work, but the Polaris project that's been working here is really looking at the social impacts of that, socioeconomic impacts. And so Aisha is this is her second trip here and gathering information on that. So where we started way back with the Stakes for Stakeholders and Sue Flensburg, who was really a key person with that, as well as Gabe. These are like the godfathers and godmothers of the Stakes program we have in the house here. Mike Davis has always been a big supporter. Really, this project was brought up to really deliver data products to communities, but products that they helped to create, that we co-produce together, that they collect the data, they're out there in the field seeing the changes and reporting on those. And so it was really it seems like common sense. You want to have communities collect their own data, but this was one of the first times that we were able to actually implement that and have it be sustainable. The state program has grown remarkably. And another big factor of it, and as someone coming from the university, I'm always trying to create more capacity to do this work. So I'm always trying to train students and bring students into rural Alaska to have them learn how to interact with people, to live in these somewhat more difficult conditions and up in Fairbanks, and just really understand that the work that they're doing is not just work in science, but it's actually work for people that's going to deliver for the people and be prioritized and kind of guided by the people in the community. So it's really is student-driven research. And I really, this is a Rich Bazard, Mike Lettering, Roberta Glenn, Reese Bogardus, Jesse Christian, Harper Baldwin, and now Steph Clausen, all graduate students that have focused on the research here and contributed. And so this is a lot of new people. A lot of these people have jobs in the state now. I'll go into that a little bit more, but really key point there. And I wanted to call out Shirley Andrews, who is from Leadlock, and she's their IGAP coordinator there. It was Shirley's idea, talking to Sue way back, about, man, there's a lot of erosion here. Is there something that we can do in our community to monitor this and understand it? And so that was really the seed for the Stakes for Stakeholders project. Sue ran with that priority, that community need, and put together the team for us to do this work. So I'd like to call out, that would really be the godmother of the Stakes program there. And this has a lot of familiar faces in it. This is our workshop back in 2016. We came here, we brought 12 different villages together through Sue's networking with BB&A. And we all came here to this campus and we learned how to measure coastal changes in a variety of different ways. So a lot of cool characters here that have gone on to do a number of different things, and it was a really incredible model of a good workshop. And so this was a video. It's just a 3-minute video. It really gives a good summary of the erosion program. And this was a filmmaker, Ryan Peterson, who did this. And it's really, I use this in my classes. I use this when I go to schools in other villages to just really show them what we're about and what the meaning is behind all of our research. So I'll start this up. Renee, I think everyone knows you, but do you want to just introduce yourself real quick? I have your little spot coming up in just a minute, but.
I've been working with Chris since about 3 years on the.
Yeah, longer, like 4 or 5, or I'm flying. Good, yeah, and Renee's gonna give some of her observations in a couple minutes here. So here we go, Stakes for Stakes.
was about the end of it there. See here. Get Paul's last statement.
All right, yeah, so that was a great Alaska Sea Grant sponsored film. That was the cheapest film we ever had done. It was $3,500. Now I'm paying the filmmaker like $60,000 to make a film, so he's growing a lot. Renee, do you want to say a few things just about being there at the start of setting up the Kanakanak Flats and then being out there with us the last couple days? Kind of your observations and what you saw out there.
Yeah, from when I first started with Chris, 2 years ago. I was, oh, yeah, I'll go help him, didn't think that I'd continue to, help him every year, and I got more interested in the erosion monitoring and how it's affecting our coastlines. And like you've seen in the video, up at the sewer lagoon, the infrastructure there is at risk for ending up in the bay. It's amazing to be alongside Chris and his grad students to be a part of it and be out there firsthand and see the change. We set up a site on Kanakanak Road right below Carol Lucker's home a couple of years ago. And it's the erosion that's happening there is significant. Just within the last year, from when we were out there last year to this year, there's some spots we lost 10 feet. I mean, it's significant. And projects like this are vital to figuring out how us as a community are going to ensure that we still have access to the hospital. That it erosion ends up wiping out Kanakanak Road at that spot. What are we going to do to get to Kanakanak Hospital? That's our only health care in the city. It's the #1 employer. So programs like this are going to help get grant funding to ensure that we can still access a hospital. It's vital. When I first started this project with Chris, I was like, erosion monitoring, we're years away from, having to worry about infrastructure in our community. And no, it's here, man. It's here. So I'm glad to be working alongside Chris. He can keep me in contact. Today, I don't know what he's doing and when he's in town, and hopefully we'll be able to not just do the monitoring, we'll be able to do something about it.
Awesome.
Yeah, I enjoy the project. And I volunteer. I don't pay to walk alongside Chris and obtain his knowledge. So as long as I'm in Dillingham and able to move, I'll be here, Chris.
Great, thank you. Yeah, thanks so much, Renee. Yeah, I mean, Renee was, when I brought in the video, that was 2021. And that was Reese, who's now almost got his PhD, and Roberta Glenn, who is in Japan right now representing Alaska in an indigenous exchange. So these are like star students that really got a lot from working with Renee as we set these sites up and stuff. So it was really incredible. And when I usually have 3 or 4 students with me out here, and I just have one. So I reached out to Renee. I'm like, we need help. And she was there and out there. So appreciate that. And, even when we were collecting the data on this slide right here, we're actually collecting the edge of the bluff. And Renee is kind of looking at the points that are getting put on, comparing it to the survey last year. And you could see a huge amount of change. There's like 10 feet of change in just 1 year. So this is real stuff here. So I'll get into some of the preliminary results. Of course, in these things, there's always so much to present, right? So we slim this way down, but we have some products coming out, and we're happy to kind of talk more about the results in a side meeting. But one of the things that we've done, and this is the work of Mike Letchering, who got his PhD last year. He's a professor now at UAF in the history department. He spent a lot of time working with historical aerial imagery all the way up to modern satellite imagery to understand how the shorelines have changed in Dillingham to give us this longer term perspective. So we're looking at it since 1980 and the changes that have happened. And you can see in these images, these are the delineated lines of the shore based on those historical and modern aerial imagery. And so you can see these different areas, you can see a lot of change. So the blue line out here is back in 1980, and then the yellow line, the purple line's 2020, and so forth. And so this work is called shoreline change analysis, and it's done in a geographic information system in a computer. And what it does is cast transects all the way around the whole community. So those are all transects, and this is actually the most recent shoreline, 2022. This is the 1980 shoreline out here. This is the shoreline change envelope of the total amount of change. And this computer tool basically calculates the rate of change, how many meters per year at each of these transects. So it's a really accurate way of understanding how the coast is changing across the whole community. And so here's the sewage lagoon is certainly one of the higher rates of change. But in this one, you can see here kind of the high spot areas of the work here. So sewage lagoon, these red's bad, red's a lot of erosion, 207 meters at 5.2 meters per year. So, that's 12, 13 feet per year on average since 1980. It's not even going by average now, it's kind of accelerating. So, and then, other areas out at the hospital, much lower rate, only 21 meters over that period at 0.72 meters a year, but that's still a foot to 1 to 3 feet per year that is eroding there. And then up at, this is just past Squaw Creek there, you have pretty significant erosion there as well, 190 meters at about 5 meters per year. So there's certainly a lot of change happening out there. And some of the interesting thing that Mike did, and this is going to be part of a paper that we have community co-authors on and stuff that I need to work on, but it's very close to being submitted for publication. And this graph is a little confusing, but I'm going to walk you through it because it's important. So the blue is 1980 to 2011. So I said about those transects going across all of Dillingham. So this is transect 1. We have 388 transects across all of Dillingham. This is the sewage lagoon. This would be kind of the harbor area. And so this would be the hospital way up here. So we're basically going from sewage lagoon to the hospital. And the blue is the average rate of change. So rate of change meters per year from 1980 to 2011. So that about a decade, the blue. And then the yellow or orange is 2011 to 2020. So that's the next decade. And you can see the orange popping up quite a bit higher here from the last decade over the previous decade before that. So in the average from 1980 to 2011 was minus 2.3 meters per year. And now in the next decade, it's jumped up to minus 3.4 meters a year of erosion. So that's pretty significant in itself. And then, we have the last few years that all the observations show it's accelerated. There's a lot more erosion occurring recently. So this is kind of the evidence, this is the first evidence that we have in a lot of communities that, yes, there is an acceleration of coastal erosion at this location. And then the interesting thing is now, Todd, who many of you know, always talked about precipitation as being the driver of some of the erosion here, and not so much the sea ice. I remember he scolded me. It's not the sea ice. It's not the sea ice. It's the precipitation. It's the runoff, groundwater coming out the face of the bluff and eroding it. And so this is a graph that shows NOAA data that is basically precipitation per year amount. And you can see that this period, that decade that we talked about, there's a lower rate of erosion. There was less precipitation. And then from the last decade, we've had an increase in precipitation here in Dillingham. Now, this is a little bit like a discussion where, it's a correlation, but it's not like, it needs more work, but clearly the erosion is tied to the increase in precipitation. So there is that factor there. So another set of work that we do, and this is what really takes a lot of time. This is what we do when we come to the field. We do these cross-shore profiles, and this is where we're running from up on the bluff or, the berm or in the forest in some cases, and then going down and taking GPS points all the way down to the water level. So these red X's are areas that we would take a GPS point with our survey. And so we've done this across the community in all of these different locations, 40 locations across the community. And so this is what we've been out measuring over the last few days, and we still got quite a bit of work to do there. And what this provides to us is a graph like this. So this is a very simple look at the sewage lagoon and how that bluff has changed here. I'll put this one up. And so here in the green is 2024. The black is 2016. So we actually have 9 years of data represented here. And we have this year's shoreline. And you can see this is 20 meters between these. And so you have a major, you have like 30, 35 meters of erosion happening right at the sewage lagoon over that period, which is a lot. And when we were down there a couple days ago, it's startling how quickly that area has changed. But this is a really wonderful way of looking at those changes. This is Kanakanak Flats, where Renee helped us collect some data yesterday. Another really high rate. We have data from 2021 there to 2024, and it's another 15, 18 meters of erosion there. So a lot. All right, so that's kind of like a look at that long-term trends that we're seeing. So that's 40 years of shoreline change here. And now we've gone out and done the topographic surveys. We're getting that almost annual change that's happening. And so that allows us to understand things. Clearly Dillingham is eroding parts of it very fast. We certainly see the highest rates of erosion are in those peat areas. Those areas where at one time the river shifted, the shoreline built out around that with all those peat bogs. And now the river's shifting the other way and eating up all that material. Some of the bluffs are a little bit more secure. But now we have some new blood coming into this work. So I'm going to hand it over to Steph. And so it's always good to get new students involved here because they bring a new enthusiasm, a new insight into some of the changes that are happening.
Yeah, so I'm just gonna say a few words about how the survey's been going this year. Chris just presented the data from past surveys, but yeah, so we've had a busy couple of days. We got here about 3 days ago, and we spent just about every evening down on the beach, taking advantage of the low tides, getting those profiles. So we started here. We flew in, set up the base, and immediately started measuring profiles. So we started here on the side of the harbor and walked all the way down, made it to Amu Creek, I believe. And then, yeah, so every evening we just started measuring the profiles. And we noticed a lot of significant erosion in spots. You can see this truck here peeking out. It's about ready to go, probably in a year. This is a pretty significant slump that I'm standing on. You can see these nets here seem to not be doing very much. I think these pictures were taken around Shade Spot. I think that's south of Amu Creek, something like that. That's one of the spots we noticed the most erosion. And we also noticed a lot by the Sewage Lagoon and Kanakanak Beach. This is a thing I wanted to just bring up today because it's a potential new area of interest that we could measure. This is Old Beach, or Old Village, down by the hospital. Many of you probably know what it is. We've heard from some people that it's in danger of erosion, so it makes a lot of sense for us to go measure that. But we wanted to present that idea and get people's thoughts before we just go start surveying. So if you have thoughts or ideas about that, please share them maybe after. Oh, sorry. I was also going to say a few words about my project. So I'm pretty early in the process of making it all. Just done my first semester, but basically what I want to do is build on a lot of the work we've been doing in Dillingham and move that to ADCA and Macoria. So Chris's lab has already done a number of field surveys doing these profiles there. And but there hasn't been a real hazard analysis to see what community resources are in danger, stuff like that. So that's what I want to do in those villages. And then hopefully as a result of that project, I'll have data products and maps like Chris showed to give to them so that they can make a response plan. That's kind of all I have to say, so I'll hand it off to Aisha.
I just want to say a few words about why I'm here and the project that I'm doing here as well. So my name is Ayşe. The spelling is not really helpful. I'm originally from Turkey. That's why the spelling's like that. I came to the US 5 years ago to pursue my graduate studies. I got my master's and now I'm a PhD student in sociology, rural sociology and demography. So I'm working also under the Polaris project that has been going on in this community for about 6-7 years and other communities in the Bristol Bay region. So that's a very tough picture of mine. Thank you for putting that. Yeah, so what I do here is I talk to the residents of the community about the changes that they see in the environment and how that impacts the food, the grocery store foods or subsistence way of life here. And also things related to migration of people, why people like to stay here, the things that keep them here, or the community's strengths, and how we can make the community strong moving forward, despite the changes in the environment and other things. And if there are people who are planning to leave, and I ask them, why do they leave? Will they return? I would like to learn from both youth, elders, native and non-native people in this community and get to learn about their perspectives, the way they describe it. So I have some questions that I brought with me, but I'm changing them, adapting them as I hear from the community residents and try to connect the big picture. So I'm letting them describe what is the problem, what's going on, what's the environmental changes that they see, how they're impacting their lives. And yeah, so I look at this relationship at both the household level, individual level, as well as very macro level. So depending on people's livelihoods, they tell me, different parts of this big picture. I've been here since last Thursday, so I talked to quite a few folks already, and in this audience, I also have people that I will be interviewing. However, yeah, all this conversation is confidential. So the way it works is that I have a recorder. I ask them if I can record them, if they feel comfortable with that. And when I go back home, I transcribe them to text so that I can work with that text and make a summary of all the things I've learned. And my hope is to be able to come back to the community and give back what I learned and share it with you and ask, does this make sense? Or am I interpreting everything right? But does this make sense to you? And hopefully that will inform the community about the things that we could do to improve the life here, to make the community more strong and viable into the future. So that's my dissertation project, led by me, but funded by the Polaris Project and National Science Foundation. So, yeah. If you would like to talk to me about your experiences living here, the things that you saw, you can contact me at my number. one of the things I've learned that I don't have to write the entire phone number. I can just put the 4 digits and people will know. So I think I'm a quick learner, so that's what I do. I listen, I learn, and I hope to apply them. So yeah, my number is 1598, and we also have some surveys, polar surveys in the community. Maybe you already took them, or maybe you already saw them. That's the surveys look like this. So we send a postcard to each person's PO box, or we also distribute them at the stores or the library and so on. So there are about four surveys asking about various aspects of life, food, climate change, environmental change, and so on and so forth. And that will also help us learn at a faster rate too about the community. So yeah, that's about what I do. Thank you.
Great, thanks, IJ. Good, so it's great to hear of the new student projects here. Excited to see some of the results of that stuff. So I wanted to talk about a few of the outcomes of the work, and then we'll open it up for questions and discussion. A lot of important outcomes come out of this, and it's, you know, the most important are really the data products that have fed into different funding proposals and stuff. So this was a figure that Mike Lettering made for Chris Laddick when he was helping Dillingham prepare a funding proposal to try to get some money for the sewage lagoon. And this went in and went to Congress, and ended up, it was a $4 or $5 million grant that the city was able to get. And it was through data products, just as simple as this. They didn't want all the data, they didn't want anything, they just wanted a very simple figure like this. So we've been able to provide a number of different products like that. You know, again, I come back to the students, because the students are really our future, right? Whether it's the youth or the college students, graduate, PhD, masters, it really is key. And here's Cassandra Johnson. She was a key partner here as well, and worked closely with Roberta Glenn, whose whole master's thesis was, how do you make maps that community members can understand and be, you know, that are accessible to people, not just scientists. And so Roberta went to 5 different communities and worked on these maps and got a lot of feedback through that process. So incredible places she's been. And then here's Mike. Mike's been gracious enough. He went down the beach with us the other day. He had us, we just showed up at his house the first night with all our equipment and said, how you doing, Mike? And took some points. And we just really appreciate this type of mentoring of folks that have lived here for a long time and really have an understanding, and then are able to work with the students. And of course, Sue has mentored like every one of my students, and it's always really incredible. One of my students, Jessica Christian, she graduated with her master's 1 or 2 years ago, and she actually published this great papers in Frontier of Science. It's a very high impact journal. It's all on the community-based monitoring methods that we develop here. So we got a publication there, and really significant paper to come out. And then one of the big financial gains for the work has been the funding by the National Science Foundation of the Alaska Coastal Cooperatives Action Project. So this was a $14 million grant that we got about 2 years ago, a year and a half ago. And really our goals from this Alaska Coastal Cooperative were all formed through our work with Stakes for Stakeholders. That was the foundation. And our goals come directly from talking to all these communities that we had the privilege of working with, including enhancing communication. So communication between the university, between communities, between agencies, between other stakeholders, and really trying to identify those shared goals to create that synergy we need to get stuff done. Advancing applied science. So that goes back to science, not just for science sake, but science that delivers to the community the products that they need, that they prioritize. And then the last one is building technical capacity, which is universally, everyone knows we need more technical capacity in rural Alaska. Communities want to take their own measurements. They want to be able to use these different instruments. They want to be able to share their indigenous knowledge and have it incorporated into the science. So this is a great project that's ongoing. One of the first outcomes of that project that really directly impacted the Bristol Bay campuses, we held a teacher training course last summer where we took students from Homer on the Tustamina all the way to Kodiak and then to Chignik Bay, and actually spent 4 days in the bay there, learning about the area, learning about the indigenous knowledge. We held a youth camp, which is a really great model. And so we're really trying to emphasize those three things, you know, enhancing communication, applied science, and building technical capacity. And Matthew Balaj here works, who's the deputy director of the ACC. He's headed out to Chignik right now. He's taking our boat on the ferry from Homer, and they're running 3 consecutive youth camps in the lake, the lagoon, and the bay. And that's really addressing the priority. Every community we go to, it's not just science they want. The most important thing is to engage the youth. And so that's really one of the emphasis that we want to make in the future, is really engaging youth every way that we can. And I'll open it up for questions and discussion. So, yeah. What do you folks think here? And I know, and I'll start off by saying, like, what should we do? Because everyone's like, well, yeah, it's changing. I'm saying it's changing really fast, but we're not the decision makers of what's going to be done here. But everyone always asks us that, you know, when's the seawall coming? How can you stop this erosion? We don't have those answers. I have some ideas, you know, but mostly it's up to the community.
On that note, are you working with the city office, the city planner, or city manager?
Yeah, we provide our products to them and have, you know, and then it's kind of up to them on how they utilize that and stuff. But yeah, Alex has been in the loop with everything.
And Chad, they got also the city manager, public works director, et cetera, they got access to this, and they may be on, so. Did they do anything with it?
They're gonna use sediment tubes to try to prevent erosion. I was curious if you had talked to them about that.
No, they're working with like an engineering firm. So really, we provide the data and then, you know, potentially like to the engineering firm and others. And then the engineering firm is the one that does the geotechnical work, actually develop some solutions or mitigation strategies.
What are your ideas?
Move back. Yeah, I mean, I think certain areas where like the sewage lagoon, it makes sense to, you know, protect in place. Other areas, you know, we're not gonna stop the erosion in a lot of the areas that we were. It's too expensive. That in some cases, there's not infrastructure that might be impacted for 20 or 50 years. But I think, you know, really all over the world, people are gonna need to move back, and that presents a lot of issues. You know, we were just in Levelock, and, you know, Ray Apokadok's house is like really close to falling in. He's already moved it once, but he doesn't own the land behind him. And so it's not just as simple as, oh, just move your house back. There's a lot of other policy decisions that need to be made there. And Mike, you've done a lot out at the hospital. Yeah, so I think the hospital is a great example of being proactive, because that was years in the work. You know, that's probably 7 years ago where you started getting that funding, and
4 years ago,
yeah, okay.
get that done.
And what is it that you did?
We moved our percolation cell inland. Because we're at risk of losing the existing percolation cell.
And Stu here, so a good follow-up question to the city, because at the prior meeting when Joe Baumgartner presented, my understanding also from the mayors that there may be actual money to do improvements rather than just more analysis. So it was a little vague as to whether that's the case or not, but something that people could always ask the city about.
Chris, you were talking about Cliff Laddick, got some funding for the sewage lagoon. That wasn't for relocation though, was it?
That was more for feasibility assessment of what are the potential strategies. I'm not sure what came of that.
Because it looks like that lagoon is what your predictions. Not very far away, right?
No, it was shocking actually to see. I mean, some of the erosion in Dillingham, certain communities you go to and you're just like, wow, this is not, it's catastrophic erosion. It's when you get 10, 15, 20 feet a year being lost, that's really significant. And the erosion at the lagoon has actually gotten to where originally they were looking at putting a bulkhead and extending the bulkhead all the way around. And where they were going to put the original bulkhead, it's already eroded up to that point. So now it's kind of that mitigation strategy is out. Now it needs to move on to something else.
And is that because it's in heat in that area? Is that what's?
I think so. I mean, Todd always said, well, this is just, the river built out in that, over like the last 1,000 years in that location built out. And now the river's just coming back, and that's compounded by the loss of sea ice. Maybe that increases precipitation. But certainly the areas, when you go back to our graph, when we go, when we go back to this graph where you see the big orange spikes, that's all areas that are the peat. Those are the peat bogs that are eroding. When you have the lower areas, this is more of that bluff material. That's that really consolidated gravelly mix that's relatively hard. But each one of these spikes is that peat material. Right, that's useful in itself, I think.
Question, this information that is being presented right now is 5 years old, correct?
This last one, so yeah, 2020. So yeah, so the analysis actually, the shoreline changes to 2022 now. So it's 2-3 years outdated. So we have, what's happening over the last 3 years, is a good question. Hopefully Seth will be able to help with that.
And one thing we need to follow up on, because I'm going back in my brain, this was quite some years ago when I was still working at BB&A. We got USDA NRCS to do a massive soil survey for the entire Michigan and Chattanooga. What I don't remember is if it included Dillingham or not, but that's a lot of good data.
Mm-hmm.
We have a question in the chat.
Oh yeah, let's see. If you got a question online here, just speak up.
Yeah, Chris, I was wondering what, you mentioned that the Bureau of Indian Affairs was a collaborator. Can you talk about that relationship a little? What that entails?
Yeah, BIA was one of the original funders as part of States for Stakeholders. So that project was jointly funded from BIA and Alaska Sea Grant. And then it also had BBNA in there as a partner. So they never were really directly involved with the project, but they did provide the funding, which is really critical. And since then, we've worked with Jennifer Robinette on a number of other things, and she's at BIA right now. But as far as Dillingham goes, I'm not sure how much input they had other than the funding.
Yeah, we just came up with the idea conceptually because I wrote the BIA proposal. Nick Kinsman, who was working for Alaska Sea Grant at the time, or no, working for the state, she went after Alaska Sea Grant, but that's actually part of it.
Does that answer your question there, Adelaide?
Yes, thank you.
And it's good to have you aboard here. I've heard a lot of good stuff about your work.
You guys are doing great work too. Thank you.
Okay.
So, Chris, I want to ask you a little bit about your perspective on how communities have been able to do actionable things with information like this. You've done this project in a bunch of different communities across a number of different years, and you probably observed what steps they've been able to take with it. What kind of commonalities do you see in places that have been successful in using this, and what things that they've been able to put in place? There's like a group of factors that sort of makes this data especially valuable and usable to take forward for some solutions.
Yeah, I think when I think of all the communities we work with, and it's 15 or 18 or somewhere around there, like it really comes down to the people that are running the show in the communities. And it's often an excellent tribal administrator that gets along really well with a city that gets along really well with the corporation. And then when those three entities are working really closely together, they're able to use these products to get funding. They're able to say, okay, let's work together on this thing. So ACK is a community like that, where it's totally run by the tribe. They don't even have a city. Well, they have a city, they don't have a corporation, I don't believe. But anyway, in ACA, they work together really well, and therefore they're able to kind of like put that effort together, out together. It's similar in some of the other communities where you have that really good partnership going. They align on a certain funding proposal, and then they're able to get money. And oftentimes that's money for new infrastructure. It's not often a seawall or something like that, but it's moving infrastructure or building new infrastructure on higher ground. I think some of the stuff like in Chignik Bay has been very progressive. Sue's worked with them a lot. They've utilized things like just the drone imagery and things like that. Some of the maps we've made to secure funding for some of their dam project and other things. So it's kind of like the more you're putting into it, when people see communities working to monitor and caring about the changes and really keeping on top of it, they're more willing to support them and give them funding to move forward with something. I haven't seen a lot of like, this is the answer, this type of seawall, or this, we were just up in northern Canada, community called Tuktoyaktuk in the spring, and they're a very progressive community. They are more progressive than any Alaska community as far as the tribe is managing an $84 million seawall that they got the money for. They're directing the engineers, they're in control, and it's this incredible very progressive seawall project. But it's millions of dollars, and it's 700 people that live there. And the Canadian government is a lot more liberal with their funding to rural communities because they just don't have as many as we do.
The only thing I'll throw out, I mean, if you go to, Lisa Murkowski some communities did get infrastructure funding. I don't know how many were actually in Bristol Bay. I don't think any. But what we've done in Chignik Bay is work with different entities, including these, Isaac Pearson, because come up with a dollar amount, you have to get a preliminary engineering report, it requires on the ground, specifications, it just goes on. So there's, at least in the Chigniks, it's been really nice to see a projection because that's what it takes to get things fixed or move.
Yeah, like another example is Nelson Lagoon. That's another community we've worked with since 2017. And it's just like the continued work there, the continued attention. Alaska Native Tribal Health Consortium got involved. They brought engineering firms, and they brought in like 10 or $15 million to Nelson Lagoon for a mitigation strategy. That includes new water storage tanks, a new plan for potential relocation down the road. So I think that energy, that enthusiasm is really key.
Great. Overall, what are some of the major mitigation techniques that are used anywhere to either slow down or not hopefully? Obviously, seawalls are one way, extremely expensive, you thought. But there are other techniques as well that are used in other places.
Yeah, I mean, from everything from let's use dump trucks and just take sand from one place where it builds up and move it to where the sand's eroding. That works, and there's a few communities that are doing that, they just want to use their millions of dollars to buy some dump trucks and front end loaders and just do that. And the guy that would drive them, and that would be their seawall that always is just moving material from one end of the spit to the other. So it's simple like that. I think bulkheads they're very expensive, but I mean, the bulkhead that's out here has been very successful, I think. There's a bulkhead in Togiak that's made out of ironwood that also has been really successful. I think, the rock revetment is like the best, but then if you don't have that quarry and that rock material, that's super expensive, but some communities are able to barge material in and use rock revetment, and that certainly helps. I've seen rock used in one area of a road is eroding out and they'll dump a bunch of rocks there, and that's gonna help the situation for 5 years or something. So I think those short-term solutions are pretty key, even if they're Band-Aids, like Band-Aids buy us more time.
How about, I'm just totally off the wall thoughts on these. How about river diversion? You ever seen that or heard of that as a technique?
Yeah, we just got the privilege to go to Igiugig and Dr. Jerry up there and Mary Hostetter and Bill Kane, who were on line here, and got to go down river and see some of the sites down there and just hear about some of the ideas. Same in Leadlock, you know, they were talking about, well, what if we like opened the channel up on the other side of the river and did that? And I just don't see Fish and Game or anyone else allowing anyone to move river courses around. We joked about it a little bit, but I don't see it happening. But there probably is people doing that in Europe or something like that, maybe. But I don't see that as a strategy here because of all the
How
fish.
about bluff contour? I mean, I can imagine where Mike and I live, for example, they were able to somehow contour. The bluff is almost vertical. Some
Yeah.
places it's more than vertical, but if it was kind of sloped and then grass and things planted, like you see highway where they have this fast growing grass, would that help in something like this, or is that just a temporary thing? Or even would that even work?
Yeah, I mean, I'm reluctant to see that. I've seen like whole, you know, let's make sand dunes and let's plant individual, you know, beach grass, and then it's wiped out in a single storm. But I think we do want to buy time, so I think short-term solutions are okay. But you know, in Levelock, one of the guys there that just works on the road crew had the great idea of like he's cutting all the trees along the bank down, because when the trees tip over, they pull these giant root wads out and cause more erosion. So they're like 20 feet back from the bank, they're cutting all their trees, throwing them over the bluff, and it's working to slow the rate of erosion, but I just don't see it working like out along your beach. You know, I talked to someone out there the other day about, oh, maybe all the fish net in Dillingham, there's probably tons of it. Maybe if you lined it along the toe of the bluff, it would slow things down, you know? But as far as like doing some big revegetation and stuff, I don't think that's a real solution.
Unrelated question. Still important. You're giving average erosion in different spots in Dillingham per year. Is there any? I'm Mike Davis, and I'm sleeping in my house 100 feet from the bluff. And how unlikely is it in 1 year or one big storm for the whole thing to collapse and Davis is 100 feet down in the water? I mean, is this something that seldom if ever happens? And can you be pretty sure that he's got 5 years or 8 years or 12 years before we really have to pick up and move? Or is this something that climate change and everything else, we could lose 100 feet in one season?
Yeah, I mean, that's a really good point. Yeah, these rates, when you do that shoreline change analysis, it's an average, and anyone that lives on the beach knows that things don't change on average, right? They change all at once. You lose, you know, at the sewage lagoon, I remember one storm, it was 10 feet of erosion in one storm. It was almost the whole year average, one single event. So just like using like a linear progression of shoreline change based on that average just doesn't work because of the randomness and the variability, storms and things like that. So I don't think that's you'd want to go by that. And we actually stopped predicting. People always just say, when's the shoreline going to be at this spot? And based on our methods, it's like it doesn't work. So we're not going to say where the shoreline's going to be. We don't know. Maybe an engineering firm would be able to know like the load of the house on this type of material. But I think you could just look at it and it looks pretty precarious. Might be better tie your house to the tree over in Jerry's yard or something.
It's it really became apparent to me strongly that erosion is more than just erosion, because if you go down the road past my house near Mike's toward what the graveyard is, I call it the Anaconda graveyard. The ground kind of is flat. and it goes all the way up toward Olsonville Flat. One spring, it became a gully, literally 150 feet of sand. It did fall in the water, it collapsed inward, and now there is a gully there that was never there before, and it happened. I would have been interesting to be visually there when it happened, but I suspect it happened in a day or less. Huge gully got formed.
Yeah,
And the only thing that makes any sense to me is that we don't only have erosion coming from the ocean and or the river, but you have underground streams and rivers going under the ground, and they must have been eating out enough that at some point the whole thing collapsed.
yeah. Yeah, I mean, we noticed that over at Kenny Shade's place. It was that really big snow year here, and then it melted, you know, and all that runoff caused a big gully right in front of his house there. And fortunately, that gully hasn't seemed to have changed much over I think it was maybe 3 years ago that happened. But yeah, that happened in a number of places, probably the same year where that gully was formed.
Where, was that on the side of the river?
Say again?
Was that on this side of the river?
It was 200 feet from my house, by Mike's house down there.
Yeah, 2 years ago, I observed the
Come
same
down, I'll show
thing
you where
on
it
the
is.
other side of the
Pretty-
river too.
Pretty impressive gully that didn't exist. It was
Yeah.
not all the way across.
I have a question, kind of having this on the same subject that Jerry's talking about, but I'm thinking this might be for Aisha too. It seems to me like part of what you're talking about and what you're talking to people about is this disappearing of what's essentially an asset, whether it's a connection to subsistence resource sites, or if it's quite simply Mike Davis's front yard going into the river. So I'm really curious of that relationship between that asset going somewhere. Basically, I live in Juneau. If my property was eroding at the rate of what I've heard Chris talk about in these results, I'd be really alarmed. And how do you navigate that conversation? And how's that going so far?
Go ahead. Good question. So you're asking how I navigate, like, because it's a hard conversation to have, or?
Correct, but also thinking like, is that a factor in people leaving and in out migration from rural Alaska, you think?
So my research is still, taking place. So I have two worries as I hear your questions. One is to protect the privacy, because I haven't interviewed too many people yet.
And we've been picking on Mike. Sorry, Mike.
Sorry, I came.
And Pat. Sorry, Pat.
And two, not sharing the results without making sure I have everything, I talk to everyone and not finding them with what I think is happening, because I'm still talking to people. Some of them are here. So I don't, the way I do this is so it's called qualitative research, and it's very exploratory. Of course, before I came here, I did my homework. So I've been reading and reading from the way back from Pennsylvania. And I've been hearing a lot and learning a lot here. This is my 6th day in the community this time. I was here 2 years ago. And what I don't want to do is prime people with what I think is happening, what I've been hearing from others. I don't want to tell them what I heard, because if I do, then they will tell me back what I told them, right? And they may forget about the specific things they always worry about in their mind. I want to not ask specific questions. That's why when you look at the slides, it says food, environment, climate. Oh, that's very broad. People say, oh, that's very broad. Of course it is, because if I define it, people will only tell me what I ask them. Kind of thing that I'm doing is the technique. I'm trained in this technique to not define things for people, but let them define what they think is happening. So erosion is something that I would like to hear more about, how that will impact people's lives. So if there are people who want to talk to me about this, question?
Yeah, after you're done.
Okay. I would love to hear more about that. So far, I haven't heard a lot about erosion. So that is probably because people who worried about erosion haven't talked to me yet. So that's the part that is missing currently, if you could help me learn more about different, those different ideas, different observations, like Noah just mentioned that, his observations. So if you have different perceptions, ideas, or fears, hopes, I would love to hear more about that. So that's how I go about doing it, without priming people, without letting them kind of influence what they will tell me. That's why I'm unfortunately today not able to share the results yet, so that it's my project that is still happening is not impacted by that. However, last week we had a Polaris team had a similar presentation here in this room. So we shared some of the results of the previous project that was taking place. And I can talk about that later at a later time. But my hope is to come back to the community and share everything that I've learned. Hope so.
So it's, again, just from listening to everybody, the bottom line is, what's the progression? What do you need? Adaptation plans, what are the specific things that you can then pursue for funding, whether it's, state, federal funding resources, private entities, because that's what it boils down to. Erosion is, we're stuck with erosion. There's some places like, was mentioned at Neck, and then the revetment wall going down by, for part of Dillingham. But people are going, what can I do? And so, again, there's been a lot of documentation of the issue, scientifically, people's comments, studies that have been done, climate change evaluation reports, adaptation plans, but ultimately people want, what's the path I can take to actually secure funding? Or, if I'm Mike and Pat, do I just pick up my house and move it to your location? Because if I remember correctly, you did design and build a house, so it could be moved. But anyways, that's the bottom line,
Yeah.
is what, people are looking for.
Exactly. I took a note just a little bit ago when the question was asked, what does it take to make that action? I actually took a note of that question because it's a question that I would love to listen.
So it'd be great if you identify what's been done. Here are the studies you can look at. Here's progressive routes you can take to then pursue, whether it's on your own, through HUD, through, the tribal council, whatever, people want pathways. So that's.
I hear that.
Patty?
And
It seems like obviously public policy is going to be driving who does what, when, who pays for what. But my question is, as a scientist, mother, as in Mother Nature, is in charge, right?
Yeah.
So how do you put that in your psyche and your analysis and your outputs?
Yeah, I mean, it's kind of hard because as a scientist that studies erosion, when we measure erosion, like we got done with a survey the other night, I was like, that was a great survey. There was like a lot of change there, but then there's someone's house falling in. So it's like, it's that kind of like irony. Sometimes like we're scientists studying these changes. It's incredible to observe and measure. But I'm at the same thing, like you're not going to be able to stop it. And that's, the real story is that, well, Alaska, especially, Alaska natives have been adapting to these changes for a long time, like 10,000 years. And there's the same, DNA indigenous people that were on the coastline here, thousands of years ago are still here. And so it's not that like this fear of, oh my God, what are we going to do? We just have to move. We can handle it. But, thinking of we're going to put $100 million seawall up in front of Dillingham, like, or, 100 million, it's like, it's just not going to happen. So now we know these other potential solutions. And, through this time, like these solutions have been lived out by, the indigenous people that lived in this area. So I think we can adapt. I think we just have to get over our fact that we want everything to be stable and secure. And we want the same beach we grew up on as a kid to be the same when we bring our grandkids there. And that's just not the way the world is right now.
I'm just kind of curious what, you guys have a lot of research going on down here in the region, but is it is it a similar story? You know, we have the same kind of issues here that are happening in Bethel and Consett. The other thing I would think would be interesting to have a sidebar is to look what happened in Newtown. I mean, they moved, but they didn't solve the problem. Right?
Mhm.
So to me, that would be an interesting footnote of someone that, but the solution wasn't really a solution.
Mhm. Yeah, you know, Dillingham is actually doing really well compared to some of the other communities where I get really sad. It's like the YK Delta. I mean, it's a sadness in that they have permafrost there and their ground is sinking rapidly and turning into water. All the ice is melting. And so they have the combination of the erosion, sea level rise, their land is sinking, and everything's turning to water, graveyards and all these other things. It's catastrophic there. Here we just have shoreline erosion. There's a lot of other issues there. There's also the poverty, and there's the lack of infrastructure and all these other things. But they have the highest population in anywhere in rural Alaska. The villages out there at Cheevac, 1,200 people. Their schools are packed and they're not leaving. They're very determined. That's the kind of the really cool thing is like they're so resilient. They're like, our people have lived here for thousands of years. We're not going anywhere. You know, you folks better figure out some new strategies and stuff, but we know how to live on the land and change. So Dillingham, I think you guys, you know, are doing well. It's just some infrastructure that is an issue, which is hard to say to someone, you're doing good, even though your house is gonna fall in, but it's not, your whole community is gonna sink into the abyss. But yeah, I would say that, you know, this work in some ways it's depressing, but like as far as changes happen, but it just is what it is. So having knowledge is really key. That's what we're trying to do is provide knowledge for people. And then, you know, it's up to all of us to actually use that knowledge, but having the information is really a key step in that, I think. All right, we've gone way over. Any other questions or anything?
Where's the pizza?
All right, thanks. Thanks everyone online. Have a good afternoon.